After I wrote the questions, we're going to start to solve them one by one. Exercise number 11. Express the edge or any edge, express the edge of a cube as a function of the cube diagonal D. Then express the surface area. So exercise number 11 here. Okay. Exercise number 11 here, we're going to write down to plot a cube first, because we want to understand what do we mean by this is a cube, and the diagonal of the cube, a line that reaches from this point to this point. Okay, so if we want to plot, we need a relation. We know that this one is x and this one is x and this one x, because you know it's a cube, and we know that this is d. Okay, this is d, and this is x and this is x. First, mainly he wants us to write, then express the edge x of a cube as a function of d. So he wants us to find x. He wants us to put x as a function of d. The blue line d. When I said d, I mean the blue line. Let me for now denote this line by s, or denote it by d1, which is the diagonal of the square of the base. So now I know that this line, the vertical line or the vertical edge, is x. So I need to find the relation between this line, the diagonal that I'm looking for, and with this diagonal and with this vertical line. But the problem is I don't know the expression of this diagonal of the square. So I'm going to do the first step, which is finding the expression of this diagonal, not the diagonal of the cube. I'm going to find the expression of the diagonal of the square. So I'm going to say, according to Pythagorean, d1 squared equal to x squared plus, because this is triangle. Okay, so I'm going to say x squared plus x squared. So d1 squared equal to 2x squared. Okay, now I want to find the relation between this one and this one. So I'm going to say right now I need d. I don't need d squared. So I'm going to find d1 equal to the square root 2x. Okay, this is d1. This is the expression of the diagonal of the square, or of the base of the cube. The next step, I'm going to find the expression of this diagonal. So I'm going just to summary. I have, okay, here, my problem is that this line, which is here, the base, is already a diagonal of some square. So first I found the d1, which is just a diagonal of the base, and then I'm going to use this d1 to express the d, or to find a relation that that assigns d1 to d and to x. So according to the Pythagorean also, d squared, this one d squared will be equal to d squared x squared, d squared plus d1 squared plus s squared, and we know that d1 squared is 2x squared, so d squared, and we're going to substitute this instead of d1, so we're going to have 2x squared plus x squared. The result going to be d squared equal to 3x squared. So he wants me to express x as a function of d, so I'm going to divide it by 3, so x squared equal to d squared divided by 3. So x will be d divided by yes, divided by square root of 3. Okay. Yeah. Cool. That's right. I'm just checking. So now he wants me the other thing that I need to find. Then express the surface area and the volume of the cube as a function of d. As soon as we found the expression of the side or the edge of the cube as a function of d, it's straightforward to express the area, of the volume or the area. So the area will be 6 squares, the area of 6 squares. So the area will be 6 multiplied by x squared. As soon as I have 6 squares, the area of the square is just x squared. So the area will be 6d squared. This will be 3 divided, this will be 3, 6 divided by 3 will be 2d squared. That's it. I don't need any denominator because I'm going to just divide it 6 by 3. So it's going to be 2d3. That's it. 2d squared. So I express the area of the surface of the cube as a function of d. What I'm going to do next, I'm going to express then express the volume of the cube. Too easy. So try it forward also. No worries. The volume, no, the volume will be x cubed. That's the law of finding the volume of the cube. It's the edge of the cube to the exponent 3. So as soon as I found x, that means the volume will be d on a 3 cubed. Okay. So v will be d cubed and 3, and we expressed the volume as a function of the variable d, which is not actually variable. It is just the length of the diagonal of the cube. We solved the exercise number 11. We can delete it right now and start to invest the space to solve the next question, but I'm going to try to solve it here. Yeah, I'm going to erase that one. To solve exercise number 12. Exercise number 12. A point P in the first, I'm going to plot here and solve in the other side, just for investing place. That's it. A point B in the first quadrant lies on the graph of the function f of x equal to the square root of x. If we want to plot, we don't need to plot, I just to plot to make things clear. This is the graph of f of x equal to the square root of x. It's very well known graph, and it expresses a function. So express the coordinate of P as a function of the slope of the line joining P to the origin. So imagine that we have P here. Just a point, and we have line that connects. This point has x and y as its coordinates, and we have the coordinates of the origin, which is 0, 0, 0, 0. He wants us to express the x and y, x as a function of the slope and y as a function of the slope, g of the slope, not any slope, as a function of the slope of this line that joining the coordinates that joining the point P with the origin. It's not a difficult to find, but it's just tricky, and he want to check that the student has fully understood the materials of the function. So first, we're going to just to prepare our things, we're going to say that y equal to the square root of x, okay, and the other point, we need to find the slope of this line. It's easy to know that from the law, which is y minus y naught equal to m x minus x naught. It's easy to know that y naught and x naught could be y and x and could be 0. I'm going to take the 0 because that will make the problem easier. So y minus 0 will be y, m divided by x minus 0, which is x, mx. So we have this relation, and we have this relation. From this relation, I want to express x and y as a function of the slope m. It's too easy. Here I'm going to say that y equal to the square root of x. So I'm going to, for example, I can take this one as a base and I can take this one as a base. So I'm going to say that m or x is already y divided by m. So I'm going to substitute this one in here. So the result will be y equal to the square root. Instead of x, I'm going to put x. Instead of x, I'm going to put y divided by m. Y divided by m. I think we can just square both sides, and the result will be very clear. When we do that, going to find y on m, okay, and by dividing by y, the result will be y equal to 1 divided by m. So this is the first function that I'm looking for, which is y as a function of m, y equal 1 on m. The other result, I'm going to bring this base, which is the square root of x equal to y, same base. But instead of putting y, I'm going to bring this equation, y equal to mx. I'm going to substitute instead of y, I'm going to say the square root of x equal to, instead of y, I'm going to say mx. Okay? Now, I'm going to divide by the square root of x. When I divide by the square root of x, the result will be, or simply I can just multiply, square both sides. So x equal to m squared x squared. And after dividing by both sides by x, the result will be 1. I don't need this anymore. The problem became clear. So after dividing by x, 1 will be equal to m squared x. That means x divided by m squared will be 1 divided by m squared. So he wants from us to express the coordinates of the function, which is x and y, as a functions of the slope of the line. So we're going to tell him that P, I want to choose another color just to be clear, that P equal to xy. Now we can write equal to P 1 m squared and just 1 on m. Okay, so we wrote the coordinates of the point P, which is x and y, as a functions of the variable m, which is the slope of the line that joins this point P with the origin. Okay. Now we have a question 13. Question 13 says, consider the point xy lying on the graph of the line. Okay, let L be the distance from the point xy to the origin OO. Write L as a function of x. So we're going to make a plan for our solution first, and then we're going to start the steps of the solution. So first we have the line. We denote the line like, no, leave it. We have the line 2x plus 4y equal to 5. We have this line. And to plot this line, just to make things easier, if you want to plot a line, you can just first put x equals 0 here. The result will be y equal to, for example, 5 by 4. So the point 0, 5 by 4. And then we will choose y equals 0 and substitute it in the line. So the result will be x 5 by 2. Yeah, 5 by 2. X equal to 5 by 2. So 5 by 2 and 0. We don't need to plot. He didn't tell us. He didn't ask us to plot, but I just wanted to plot it to make the solution clear. So I'm going to plot it. If you want to plot a line, just choose first step, take x as a 0 and find y, and then take y as a 0 and find x, and the result will be 2 points. Each point intersect with one of the axes, and it will be easy to find 0 here and 5.4, just 1 and a quarter here. So this is the first point, which is 5.4, and this is the other point, which is 2 here. Let's say 5 by 2 and 0. And if we want to plot this line, it is just a line. Okay. Now we have just a point lying on the line. For example, let's say here, for simplicity, it doesn't affect our generality. So we assume that this line is here, and we assume that this is the origin. We don't need to assume it is the origin, but we assume that this line is L. Okay? So we have a line, and we have a point xy lying under that line, and the distance from the point xy to the origin is just L. He wants us to write L as a function of x. Okay, so he wants us to write L as a function of x. Okay, this is what we need to find. And we can start from the line first. So the distance between this point and this point could be found from the law of distance, which is x2 minus x1 squared plus y2 minus y1 squared. And I mean by x2, x1, y2, y1, it's the coordinates of any 2 points in the plane. So we have this point xy, and we have this point, so I could write easily. This is just the formula here, just to make you memorize it in case you don't remember the formula. So x minus 0 squared plus y minus 0 squared. L will be x squared plus y squared. Okay? You want us to find L as a function of x. Now I have L as a function of x and y. So I need to get rid of the variable y, and it's too easy. I can find y from here. So I would tell that 2 x plus 4y equal to 5, I can move the x everything but y to the other side. So 5 minus 2x, I need just y, and then I'm going to divide by 4. So the result will be 5 minus 2x divided by 4. Let's say this one, and let's say this one, and let's say this 2. So now by substitute 2 by 1 or in 1, I'm going to make this in this. The result will be L equal to x squared plus 5 minus 2x on 4 all squared. The result will be L, which is the distance from this point to the origin, as a function of the variable x as he wanted in the book. Okay, write L as a function of y of x. He could say he could have said find the or express L as a function of the variable y, and it's too easy. I can just find x from the line and just substitute it here, and the result will be as we predicted or imagined. Now we have I cleaned the board and we're going to solve a question number 14. Consider the point xy lying on the graph of the function y equal to the square root of x minus 3. Let L be the distance between the point xy and the points xy and 4 point O. Write L as a function of y. I think it's not very difficult to solve this question because we've already solved a similar one, and we can say now we have just to, I love to plot things to make them clear, and we have this function which is x minus 3. It should be 1 2 3 from here, and this is the function y equal to x minus 3, because when you substitute 3, the result will be 0, and then it will be increased from another points. And we have these points. We have xy on the graph. Let's say here x and y, okay? And we have 4.0. It will be here because this is a 3, 4.0. And assume we have a line here. Going to put another color. We have a line here, L, okay, or a distance L. He wants us let the distance be, let L be the distance between the points x, y, and 4, O. Write L as a function of y. He wants us to find L as a function of y. I think it's became too easy to find the solution of such problems. The first thing we're going to write is finding the formula for L. So L will be the square root of the difference between these points, x minus 4 all squared and y minus 0 all squared will be y squared. And this will be the first equation, let's say, just to make our work tidy and elegant. Now we need to get rid of the x. If we get rid of the x, our problem will be easy because I want to find L as a function of the variable y. I don't need x to exist here. So I'm going to use this one. So y equal to x minus 3. I have a nice step or a nice trick. We're going to square both sides. So y squared equal to x minus 3. Okay, I'm going to add minus I'm going to add minus 1 to the both sides. So the result will be y squared minus 1 equal to x minus 3 minus 1 will be x minus 4. So I get x minus 4 here, and I just added minus 1. I want this expression on the right to be equal to this expression inside the brackets. So put 2 in 1, okay? The result will be, I'm going to substitute instead of x minus 4 inside these brackets, I'm going to put y squared minus 1 inside these brackets, and the result will be L equal to square root plus y squared, and I'm going to say y squared minus 1. You don't need to simplify it, but if you want just to simplify it and make it easier as a one polynomial inside, it's okay, and I can just do it for you in one step. So y squared will be y squared, and you have 2y squared, okay, and 2 I think it's okay. It's okay, 2y squared, and that will be, no, this will be y to 4, and minus 2y squared plus 1y squared will be minus 1y squared, and a plus 1. This is the result if you want to simplify it. Okay? To this far, I completed the questions. We've solved together the questions from to exercise 14. In the next lecture, I'm going to, me and you, in the next lecture, we're going to solve the other questions. As I remember, it's find the graph of the function, and then we have some functions that we need to find the domain of them. Okay, see you in the next lecture, and thank you.